So basically, we can continue this process, right, for different values. So key here is writing these expressions using a minus sign. That's very important. For example, x plus 4 as x minus minus 4. Then we have that form here, this form actually. X minus, okay, let me write here. X minus c, that form. That's very important. And here f of c equals to 0. So if x minus c is a factor of f of x, then we know that f of c should equals to 0 according to the factor theorem. Right? And also the other direction. If f of c equals to 0, x minus c is a factor. So therefore, it's really important creating this form. Because for example, for x plus 4, so what's the c value? You should create that minus sign. Otherwise, you can't compute c. So x minus minus 4. Hence, c equals to minus 4. That's the c value. Therefore, if x minus minus 4 is a factor of f of x, f of minus 4 equals to 0. Like that. So that's the key here. So for this problem, actually we follow this path like this. So that's why we check whether f of minus 4 equals to 0 or not. Right? You can try that. You will get a value that's not equals to 0. Yeah. But we got f of minus, sorry, what we got here? Yeah, f of 3 does not equals to 0. Therefore, f of 3 is not a factor. Then f of x minus 3 is not a factor. Then for x minus 1, you can check for this one. You can check f of 1. Whether f of 1 equals to 0 or not. Right, for this one. And also for x plus 1, f of minus 1. Once again, the idea that I mentioned. This is x minus minus 1. Now, I think, let's see, f of minus 1. You can compute that. Replace each x by minus 1. Minus 1 to the power of 3, 4 times minus 1 squared plus 1 times minus 1 minus 6. I just replace each x by minus 1. Minus 1 odd power. You multiply minus 1 odd number of times, 3 times. So that's minus 1. Here plus 4 times 1, that's 4. Then here minus 1, minus 6. I think that does not equals to 0 again. Yeah, f of minus 1. Yeah, clearly this one equals to minus 4, I think. Not equals to 0. Hence, x minus minus 1 is not a factor. Similarly, try f of 1 for the second answer choice. That is 1 to the power of 3, 4 times 1 squared plus, I think that will work. 1, 4 plus 1 minus 6, that's 0. Hence, x minus 1 is a factor. of that polynomial. That's very, very important. So that's the idea. Always remember this part. You can go both ways, right? Now let's move to another problem. Now that's slightly different, this idea. What is the remainder? For example, you can divide 8 by 4. That's just 2. Right? And therefore, 4 is a factor of 8. Because you can divide 8 without a remainder. But what about 9? Can you divide 9 by 4? So I think you will get 2 plus some decimal value, right? Actually, if we use the long division, 2 times 4, 8, 1 remains. Remainder equals to 1. But you can't just write 9 over 4 equals to 2 plus 1. Because 2 plus 1 equals to 3. The left hand side, we clearly a value that's less than 3. So this is not how we write the answer. 2 plus 1 over 4. That's how we express this situation. And clearly, this is the remainder. That's the most important part for us right now. Now, now for this problem, so polynomial is divided by x minus 2. Then what is the remainder? So I'll show you the remainder theorem. Right? This is the remainder theorem. If a polynomial f of x is divided by x minus c, the remainder is f of c. We can connect this idea with factor theorem actually. I'll show you with a different example. It's you can connect factor theorem and remainder theorem. So you will see that here. Now, so let me write that idea. If a polynomial f of x is divided by x minus c, then the remainder is f minus c. Right? So let me write remainder r equals to f of c. Right? So if you divide f of x by x minus c, then the remainder, this direction, remainder equals to f of c. Remainder, it's like this. Here in this occasion, we got 1. We are talking about something like that. So in this case, it's quite easy, I think. So we are dividing f of x, which is that function, we divide that by x minus 2. X minus 2. Now, once again, the key here is identifying the c value. So c value is 2. So to identify that, to recognize that, this minus sign is quite important, vital, that minus sign. Sometimes you might get x plus 2, then you should create that minus sign, like the factor theorem. We did that in the factor theorem. Now, after creating that form, it's very easy, very straightforward actually. Now the remainder, we do have a formula, that is the remainder equals to f of c. But this occasion, c equals to 2. Hence f of 2. It's about computing f of 2. You can easily do that because here's f of x here. Just replace x by 2. So f of 2 equals like this. Then simplify. Right? 8 plus 3, 11. Here minus 14. 11 minus 14, which is minus 3. Now that's the remainder. But the question is, now what's the remainder for this division? If you divide 8 by 4, what's the remainder? That's the question. What's the remainder? Remainder equals to 0 for that case. Then what it tells us? Yeah. This occasion, remainder equals to 0. Because you can divide 8 by 4 without a remainder. So remainder equals to 0. Right? That's very important. Now, how would you connect that idea now? That's the question. Remainder equals to 0 and a factor. When will you get remainder equals to 0? That's the question. We can discuss about that through the next problem. Because what if this value equals to 0? That's the next question. That way, by doing that, we will be able to connect remainder theorem and factor theorem. Think about that. I'll explain in the next class, in the next session. So idea is very simple. Right? But in this occasion, for the remainder theorem, we always follow this direction. Right? Can't really go backwards like factor theorem. Right? So this is the direction we follow. If f of x divided by x minus c, then the remainder is f of c. We have a method to compute the remainder. That's the most important thing. My question is, what will happen if this remainder equals to 0? I think that way you will get a situation like this. Then we can connect this idea with factor theorem. Okay. Thank you very much.